Hi, this is Tony Northrup for Train Signal, and in this video lesson I'm going to discuss endpoint device security for the SSCP certification exam. What are endpoint devices? Well, they're all the little things that are attached to the edges of your network. PCs, tablets, smartphones, flash drives, and even things like printouts. These are anything that can carry data or might need to be managed. First, let's talk about one of the most dangerous of these endpoint devices, and that's USB flash drives. What are the risks of USB flash drives? Well, people will copy confidential data to them and then they'll walk out of your office with them. All of your file permissions don't make any difference. Any auditing that you have in place completely bypassed. Once those files are on that flash drive, anything can happen to it. You lose complete control over it. Pretty scary, isn't it? Even if the user means well, even if they've been trained in security best practices, well, what happens when they just drop it in the parking lot and somebody else picks it up? It's a real world scenario and it happens all the time. They're also easily stolen by somebody with malicious intent. So there are a bunch of different ways you can mitigate this. I think the easiest is just to block it. Now, you can't necessarily do this on every platform, but if you use, for example, Microsoft Active Directory, you can enable a setting that will block any managed computer in your organization from connecting any sort of removable storage. And that will certainly decrease the chances that users will take data off your network with a flash drive. You can also, of course, physically search your employees when they go in and out of the office, and some places will do this. You'll get patted down and they will open up your briefcase and flip through it. Of course, this only stops the least determined of the users because flash drives are teeny tiny little things nowadays. Have you seen micro SD cards? My goodness, they're minuscule and they could be hidden anywhere and basically undetectable. So physical searches don't necessarily solve the problem for you. Instead of that, you can rely on actual security training. Talk to your employees and tell them what the risks are. Tell them if you copy your files to this drive, you might lose it, somebody could steal it, and then we're in a lot of trouble, right? Encryption can really help here too, either software or hardware-based encryption. Hardware-based encryption is a capability that's built into the USB flash drive. So anything you write to it is automatically encrypted by the flash drive itself. Of course, this requires the flash drive to have some extra logic in it, which means it's going to be a little more expensive than the average flash drive. Software-based encryption can be a lot more affordable. There are several different free options out there, but one that I've used a lot is Bitlocker To Go, which is included with most business editions of Windows. For example, Windows 8 Enterprise and Windows 8 Professional have Bitlocker To Go. And all you do is you plug the drive in there and then you enable encryption on it. Unless you train your users, it won't happen by default, but you can also use group policy to go in and require all flash drives connected to be automatically encrypted. And unless the user allows the encryption to happen, well, they won't be able to copy any files to it. So it doesn't give you foolproof security, but it helps. Another increasingly common endpoint device are smartphones and tablets, which, though they're different form factors, the software is so similar that I think they're functionally the same. Look at the gal on the right there. She's actually using both at the same time. Isn't she high-tech? Well, just like USB flash drives, these devices can store lots of confidential data, and they're also easily lost or stolen. So somebody copies a file to their phone or tablet and then they lose it, you've lost the file. In many ways, smartphones and tablets are actually much scarier than flash drives just because they're connected to the internet at all times. That means there's a possibility of them getting hacked online and immediately transferring the data anywhere in the world. Pretty scary stuff if you think about it. I really suggest as a mitigation that you just keep these devices as far from your network as you possibly can. Other risks of smartphones and tablets are employees will use them for social networking. And because they have both still and video cameras built into them, well, they can go and take pictures of confidential stuff. They can take pictures of your secret data center designs. Even if you use digital rights management to prevent people from copying or forwarding documents on your network, well, they can open it up, pull out their cell phone, and take a picture of their monitor and all the data on it. These devices are really scary from a security perspective. So besides simply blocking them from your network, which is difficult to do because employees need their phones, right? They got to be able to receive emergency phone calls from their spouses or their kids. They need to be able to take a picture of their lunch for Facebook. Well, maybe they don't need to do that, but they would want to, and they're going to complain if you take their smartphones away from them. Take it from me. So a few of the things you can do to manage them are, well, first and foremost, I would say security training. Teach your employees not to take pictures of confidential stuff. And maybe not to tip their hat in social networking, Keep their business life off their Facebook. A lot of companies nowadays will issue employees smartphones that are managed. So you can configure most types of smartphones with restricted security. To improve their security, you can encrypt their contents and allow them only to download certain types of data and run certain types of apps. So these managed smartphones have much lower security risks than the typical unmanaged consumer smartphone. So if you issue your employees a smartphone, suddenly it's not so bad to tell them they can't bring their own smartphone, right? You're just telling them, hey, don't use your iPhone from home. I'm going to give you this Android device or this Windows 8 phone. Only use it here. And I don't feel so bad about the security guard patting you down to make sure you're not bringing in some rogue device because I've configured this smartphone so you can get calls from your kids, but you can't take pictures of confidential documents, so we're in much better shape if you use that. By default, most of these smartphones just require you to swipe to open it up. Go ahead and tell users to lock their phones with a password or a passcode that at least improves security in case they lose it. One nice feature that smartphones and tablets have that flash drives don't are GPS tracking. So if somebody loses it, you can track it down. Sometimes you can even track it down if somebody steals it, as long as they're not so sophisticated that they shut the device off or put it in a lead box or something clever like that. They also have remote wipe capabilities. And a lot of people don't know this, but you can usually call your cell phone carrier and tell them to remotely wipe your phone, and they'll do it, and they'll just wipe it clean. In enterprises, this is an important feature, and in fact, it's a big part of issuing managed smartphones is the ability to wipe these phones from within your IT infrastructure without necessarily having to call AT&T or Verizon. You can do it from your own servers as an IT guy, just wipe somebody's phone. So that day when Mary calls you on a different phone, it's just like, I lost my smartphone. You can just log into an app and have it wiped wherever it is. And Mary just lost it in the couch or something because she's always doing that. But at least you'll know for sure that nobody's going to find it and get the data on it. And then, of course, because it's a managed infrastructure, you'll have a backup of the device and you can just restore it to a different copy of the same phone and hand it to her and she's back up and running. Maybe the scariest of all is the recent trend towards BYOD. That's bring your own device. This basically refers to any sort of device that users want to use, but often it's their own custom PC. PCs are coming out in lots of different form factors now, and they're very, very capable. They look like tablets, but they run full Windows apps, and you know what else? They're just as susceptible to malware, worms, viruses, Trojan horses as any other Windows or Mac PC, but they're teeny tiny. You could slip them in somebody's purse. But they could run a million different pieces of malware. They don't have the protection that the smartphone and tablet dedicated operating systems do. So the risk of them being hacked are much, much greater than for smartphones and tablets. Companies are handling this in different ways. Many organizations continue to simply forbid bring your own device type policies. They say, you cannot connect your home PC to our network in any way because we don't trust it. So we'll issue you a PC and you can use only that. However, there are companies who are trying to be more progressive because there are so many users that say, you're giving me this like 1995 8-pound laptop and it just doesn't compete with this 1.3 pound ultralight laptop, so I want to use my own laptop, just let me use it. Some companies are starting to say, okay, we can do that with a few clauses. So some of those clauses that you can put in to mitigate the risks are to require everybody use passwords. Seems pretty obvious, right? Don't allow log on automatically. If they're away from the computer for a limited amount of time or they close the lid, make sure it locks. You can use this feature of Windows called Windows To Go, and this isn't going to be on the exam. I just think it's really cool. You can install Windows on a special type of flash drive, and then you just plug the flash drive into any PC and boot it from that flash drive, and it takes on the personality of your corporate Windows image. It's really cool. It allows you to turn any PC into an approved PC, at least software-wise. You can also mitigate the risk of data loss using hard drive encryption. There are lots of third-party tools to do this. Windows happens to have a tool called Bitlocker, which will encrypt the hard drive and make it pretty much impossible for an attacker to access the contents unless they get your recovery key. Newer PCs have a feature called Secure Boot. This is a feature that's built into the firmware, but basically it only loads a bootloader that is approved. So something signed by Microsoft or another operating system vendor. And the great thing about Secure Boot, it basically stops all forms of bootkits and rootkits. I don't know of anything that can bypass Secure Boot right now, which means that suddenly all these PCs are much more trustworthy and the risk of malware is much, much lower. All Windows 8 certified PCs have Secure Boot turned on by default. Some PCs also have GPS tracking, which, like smartphones, allows you to track them down. And some PCs will have remote wipe capability. So the first time they connect to the internet, they'll pick up your remote wipe signal and clean all the data off. And then, well, you've lost some hardware, but you haven't lost those millions and millions of dollars of confidential documents that are on the PC, right? And of course, train your users on how to handle their own PCs. Teach them to install updates automatically and run their firewall and not install untrusted attachments and just all the typical things that you would teach a PC user. Good old hard copies are still a risk you need to mitigate. People will just print out some confidential data and they'll walk away from it, or maybe they'll even just leave it on the printer for somebody else to find. That happens a lot. You have no control over hard copies. You can't track them down. You can't remote wipe them. There's no GPS capabilities built into paper as far as I know. So this is a common risk that's been around since printers. There are a few different ways to mitigate it, and frankly, none of them work especially well. I mean, you can pat down your employees and go through their briefcases to make sure they don't have any paperwork, but they're going to need to take some paperwork home sometimes, and then what, you're going to trust a security guy to determine whether it's confidential or public or whatnot? Well, it doesn't work out very well, but it is an option. Of course, the best option is just to train your employees, teach them what documents to print and what not to print, and then make sure your employees are trustworthy. You can also limit access to printers and don't allow users who don't have the proper security training or who aren't trusted to print stuff. And finally, just teach your users to shred anything before it goes in the trash. I tell them to shred everything. I don't even want them to think, is this confidential or not? I want every piece of paper shredded. And then you teach the janitorial staff, if they see a piece of paper in a basket somewhere, shred it. Let's go over some client security fundamental concepts. One of the coolest new computing trends is virtualization. And it's not just for clients, it's also for servers. And I tried to visualize it here, but the way virtualization works is the host computer, usually a PC, will run a virtual machine inside of it. And the virtual machine pretends to be just about anything. The virtual machine could be an old computer running Windows 98 that's required for some legacy app that you have. Or it could be an entire network with firewalls and switches and routers and many different computers all connected to each other to communicate in a private way. You can simulate just about anything with virtual machines, even specialized hardware devices like tablets and smartphones. That's how developers write and test their apps, of course, using virtualization like this. Virtualization requires some extra thinking about security. It has some real strengths. First, because you can take 10 different servers and cram them onto a single box. It reduces cost. It also centralizes your management because you don't have 10 physical servers to manage anymore. They're all running on one computer. And because these computers can all share resources amongst each other, it improves both your scalability and availability. Well, it might be obvious if you put 10 small computers on one big computer, that can improve the scalability of any one PC. But the way it improves availability is you can take these 10 computers and put them on 2 computers. And if one of those computers fails, they can transfer over to the other. Now, of course, virtually any service can be clustered amongst different computers nowadays for failover in the event of a hardware failure. But where virtualization helps is it reduces the cost of the hardware. So if you had 10 different servers that you wanted to cluster for redundancy, it'd be pretty expensive to install 10 different clusters. Instead, you install one cluster and you put all 10 servers on that cluster. the cluster suddenly becomes much more affordable. Virtual machines also work to sandbox the guest operating system. Now, sandbox is a pretty standard security term, but basically it just means that they set up a walled garden, a little special area where the virtual machine thinks it's running on dedicated hardware, but it's really not. And the host operating system can limit what the guest is allowed to do. Ultimately, the host operating system can control every aspect of what runs in the client computer, and you have much more control than you would over a dedicated physical machine. So the host operating system could limit how many processor cycles the client gets, or how many network communications it could send out on the network. Virtualization also carries some extra risks that you don't have with physical machines. The host server has access to all of the client operating system's memory, at least in theory. In practice, I don't know that you'd be able to go in and actually interpret the contents of the memory of the virtual machines, but in theory, a skilled hacker could definitely access the contents of any of the virtual machines running on the host. In other words, hack the host, hack the VMs. So if it's not a cluster and that virtual machine host fails, all the virtual machines fail on it. So one hardware failure could result in 10 virtual machines going down, or sometimes 100 virtual machines. Now, there have been real-world examples of virtual machines hacking both other virtual machines and the host computer. So in theory, this sandbox, this walled garden that I was talking about, would prevent the virtual machines from ever leaving their matrix-like reality. But in practice, there have been some actual hacks that allowed the virtual machines to overtake the host operating system, meaning that you might be using a virtual machine to test some malware, thinking that the virtual machine would keep it isolated, but it doesn't actually necessarily keep it isolated. These examples have been pretty few and far between, but in theory, it can still happen. When I talk about virtual machines crossing over and communicating using covert channels, well, in theory, you should be able to say that the database server and the application server virtual machines can't communicate directly. But with every modern virtual machine application that I'm aware of, there are covert channels. So the database server virtual machine could consume 100% of the processor resources for, say, 1 second. And that could be a special signal to the application server to perform some other type of task. Anytime a resource can be limited on the host computer, covert communications are possible between virtual machines. So besides the processor, a virtual machine could consume a lot of memory utilization, or disk space, or disk I/O, or even bus utilization. So anytime there are shared resources that could possibly become limited, it's an opportunity for virtual machines to communicate back and forth. Now I'm going to talk about thick clients and thin clients. Up first, thick clients. Everybody's familiar with thick clients. These are just regular PCs and Macs. They run a full operating system like Windows or Mac OS or even Linux, and the apps run locally. They have hard drives and memory and processor, and they can store gigabytes and gigabytes of data locally. Regular computers. Now let's talk about how we handle thick client security. Well, these are really powerful machines, and there are lots and lots of tools available for them. So that's a positive. You can install dozens of different anti-malware apps and firewall apps on these computers. You can manage them using group policy and scripting tools. They're very, very flexible platforms, and that gives you the ultimate control over them. Thick clients also don't need network access to run applications. That's in contrast to thin clients that we'll discuss a little bit later. They also have a great deal of power and can run just about any app, whether it's Word or OpenOffice or 100 other things that you might want to run, giving you more options, allowing you to choose the most secure app possible. Thick client security also has some real drawbacks. Well, the hardware is really expensive. So why is that a security drawback? Because you might want to spend your money somewhere else, right? Maybe you want to get that new firewall or intrusion detection system, but you're spending all your money on these big hard drives that are mostly being wasted. The software is expensive too, because you have to get a full operating system and then full versions of Office apps and every other application that the users are going to need. They're also a real pain to update. I mean, all the modern operating systems have automatic update systems, but still. And all the applications running on them might not, and then you have to worry about all the different drivers for the hardware that's going to be attached to them, and, well, updates are a pain. And just in theory, the more complex any device is, the greater the attack surface, and thus the greater the potential there are for vulnerabilities. And there's just about nothing more complex than the traditional thick client PC. On top of all of this, any PC can be stolen, but mobile PCs are really likely to be stolen. They're stolen all the time. You know why? Because they're expensive. And somebody wants to steal them and pawn them and make a few quick bucks. So you got to keep your eye on those mobile PCs. And in an enterprise with thousands of computers out there, they're going to get stolen every day. And when they get stolen, the data on them could be compromised. Hopefully it's sold off to somebody who doesn't care about the data and just wanted to make a few bucks selling the hardware, but you never know who's attacking your data. Now let's talk about thin clients. And thin clients are certainly more cutting edge than thick clients, but they've still been around for 10 or 15 years. Basically, a thin client is just a little more than a display and some method for user input, a keyboard and a mouse. And just today I was looking at some thin client hardware from Samsung, and it's just a monitor, a keyboard, and a mouse, and you plug the monitor directly into the network. It's pretty amazing. It connects to a server somewhere in the cloud and just pulls down the display from the server. The server is responsible for running any apps that you have, for example, Microsoft Office or a web browser. The server just channels the video display to the monitor. That's the ultimate in thin client. Other types of thin clients might have a little more hardware. There might be a little PC-like box there with, maybe 500 megs of RAM and a really tiny, inexpensive mobile processor, or maybe even a few megabytes of local storage. But the trait that ties all thin clients together is that they rely on a server to run their apps and process their data because they just don't have the local processing capabilities. This actually brings a lot of security benefits. First, the hardware is cheap, so you can spend the money on something you'd rather spend it on, like, I don't know, IT guy salaries, right? Second, the administration is necessarily centralized because all these thin clients are connecting to a central server and running all their apps there. You manage all the apps on this one server. There's really very little that can go wrong on the clients. You just plug them into the network and they get their feed from the server that you're managing closely. This means you just need to install updates in one place. If there's a new version of Word that comes out, you install it on the app server. That's it. You don't have to go to everybody's desk. You don't have to distribute updates across the network. Everything's in one place, and trust me, it is amazingly simple to manage thin client security once you get it initially set up. There are some downsides though. While the clients themselves are less expensive, you need some big server that's going to run the apps for dozens or hundreds of different thin clients, and that server infrastructure can be pretty expensive. It also requires that the thin clients have network access. So there are some technically thin clients that can work offline. One that comes to mind are the new Google Chromebooks. The Google Chromebooks primarily rely on Google servers to run apps like word processing apps or image editing apps. However, they have some ability to process things locally, so if you're on a long train ride and you're not going to have internet access, you can still get some work done. Thin clients generally can't run apps natively, and the app server has to do some special handling to channel the video output from the app server to the thin clients, and not all apps will work properly with that. So many of the common apps that you know and love will work. Microsoft Office certainly works. So video production software won't work very well in a thin client scenario, so you probably still end up putting a big expensive workstation on your video production guy's desk. Because all the thin clients connect to an app server somewhere, it is a single point of failure. You mess up that app server, nobody's getting any work done. You could potentially bring down hundreds of thin clients and ruin your company's productivity with one poorly installed update. So make them redundant, install the app server in a cluster and test everything really carefully before you make any changes. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.